Hello, hello. Welcome back to another video by Total Developers. And today we will be completing a walkthrough on implementing ternary search in Rust. So in this video, we'll break down the concept of ternary search, explain its algorithm, and guide you through the implementation in Rust step by step. So let's get started. So in order to set up the project, let's go ahead and create a new Rust project with the cargo keyword, and let's name our project Ternary Search. Once that runs, we've successfully created the project. So now let's change our directory to Ternary Search. And as you can see, we have our project. And as you can see here, we have our project, its main function right here. So the next thing to do is to create our main ternary search function. All right, so let's go ahead and start that. And we can do this by writing fn ternary search. And then let's pass in the arguments array. And that is a reference to our signed integers, a reference to an array of signed integers. And then let's pass in our target. And that is a integer. And then let's return an option of type unsigned integer. So that's usize. And then let's go ahead and then call our ternary search recursive function that we are going to write just a few seconds. And then we pass in our array, we pass in our target, and we also pass in our starting point or starting or the beginning of the array, or our points for the left and our point for the right. And that is just our array.length -1. And then let's go ahead and now put a colon because we are going to return that at this function. And essentially here, this function is the entry point for our ternary search. It calls a recursive function with the initial parameters. So next thing to do is implement our recursive function, and that can be done like this. So we call our function called ternary search recursive, and we want to pass in our array of type of an array, which is essentially just a reference to an array of signed integers. And then we want to pass in our target, which is just an integer. And then we want to pass in our left pointer, which is again just an integer, a signed integer. And then our right pointer, which is unsigned integer. And then we want to go ahead and return our option of unsigned or usize, and then we can start our function. The first things to do is ask if our right pointer is greater than or equal to our left. We can do that by saying right greater than or equal to left. And if it is, let's enter our condition, and that is let, and then we want to let or create a variable called third. Do that by saying let third equal our right minus left divided by 3. And then we want to set our midpoints, right? So we need a mid1, and that is equal to our left pointer plus our third. And then we can create our mid pointer, mid2 pointer, and that is essentially just our right minus third. Next, we want to ask if our array at mid1 is equal to our target. So this basically is checking if we found our target, right? And if we have, let's just return our midpoint by saying sum and then passing our midpoint or mid pointer value to the target. And then we ask again if our array at mid 2 is equal to our target. We want to return our midpoint 2 or mid 2. So let's say that by sum mid 2. Great. And if we haven't found it yet, we ask if our target is less than our array's value at mid 1. Let's go ahead and return or call our ternary search recursively, basically searching again. And then we want to pass in our array, and we want to also pass in our target, and we also want to pass in the left pointer. And then we want to pass in our mid 1 pointer minus 1. And we're going to check again. So we're going to ask if or else if our target is greater than our array at mid 2, we want to recursively call our ternary search recursive function, but this time we want to pass in our array, our target, and then our midpoint 2 plus 1, and then our right pointer. And then if both of these conditions are true, we are not true, we want to default to calling our recursive algorithm or recursive function, and then we want to pass in our midpoint at midpoint 1 plus 1 here, and then our mid 2 minus 1 here. That looks like this. And then if as we remember, we had our initial condition being if our right was greater than our left, or greater than or equal to our left, we enter this. And if not, let's just return none. All right. So this is a function that divides the array into 3 parts and recursively searches the appropriate section, right? So let's go ahead and implement a way of testing this. And we can do this by just going into our main function here. Let's create an array, right? And this array needs to be sorted. So let's go pass the values that are sorted, obviously. And let's go ahead, let's put in value 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. Next, let's set a target, and we want to find the value or the point or the position of value 5. Next, let's create a match function and basically pass in our ternary search function, and then we're going to pass in a reference to our array here, as well as the target. Then we want to ask if the index, and we want to say if there is a returned value from our ternary search, we want to get that index or get the return value, and then let's print element found at index. Then let's go ahead and type in the index. And if not, or if none is returned, let's go ahead and say line element not found. Okay, great. That being said, our function should work here, and we should be able to go ahead and run this out. And instead of saying mid 2, let's go mid 3 here. That should work. Just checking to see if everything looks right, and it does. Oh, we've set this to an integer, assigned integer, but we want it to be an unsigned integer. And that now the compiler is not complaining and everything looks good. So let's go ahead and build this, and we could do that by, let's go ahead and clear, and do this by saying cargo build. It compiled successfully. Great. Let's go ahead and run it. We can do that by saying cargo run. And great. As you can see, it said element found at index 4. So we could check that by going here and counting, starting with 0. All right. 0, 1, 2, 3, 4. And great. This was ran successfully, and we found the target value. So in conclusion, let's recap. We implemented the ternary search in Rust, starting from the algorithm explanation to coding and testing. In next steps, let's try to modify the algorithm for different use cases and optimize further if needed. So by the end of the video, you should have had a solid understanding of the ternary search and how to implement it in Rust. Happy coding.